All right, guys, so this is the third part of it. So as of now, we're going to skip this next part for now. I'm going to actually do it at the end because we're on a roll when it comes to this, and this next part has very little to do with, this kind of stuff. You'll actually be seeing the next part, this part in actually calculus itself, and it's called the intermediate value thing. You guys flip the page, and we'll do this at the very end of the section. That way you guys get a little glimpse of a pretty big part of calculus itself, and you get a little hint what you guys be doing, a good chunk of it as well, right? So we're going to skip that and go on to the next page of page 27. So pretty much putting everything together, right? So how in the world are we actually going to find zeros of a polynomial? And I tried my best to give you guys a breakdown of what you're actually going to do it, 1 through 3 step 4 process. So the first thing you want to do is see how many zeros there are and finding the highest degree of the polynomial. So you just break it down how much we should have, how many zeros we have, and slowly break it down from there. So that's step 1. Step 2 is we're going to use Descartes' rule to see how many possible and or negative zeros we actually have. So using that funky theorem we had did earlier, right? When it comes to, you can see a little bit more how it would help us out here, okay? And then step 3, we're going to use the rational zero theorem to find all the possible zeros. So in other words, we do the same thing we did with the little list here. So this little list is what we're going to be doing for step 3. And then finally, step 4, we're going to use synthetic division, which is going to be your longest portion. Now, this is the reason why these take forever. We're going to use synthetic division or long division and factoring method to find the zeros of the polynomial and write it in standard form. Okay, so step 4 will literally be the longest step, believe it or not, when it comes to it. All right, so let's actually try this out. You may need more space when it comes to this. I'm not sure, but I'll try my best to put it all in that little space, the space I give you guys provided. Okay, so first off, step 1. All right, so we want to find all the real polynomials of this function here. So step 1 is see how many zeros we should have. So the highest degree here, or the degree of the polynomial, is 3. So at the very end, once we factor this, we should have 3 separate zeros, right, when it comes to it. So just gives a little glimpse, a little check if we skipped one or missed one or something like that, okay? That's step 1. So now we go on to step 2. So step 2 says we want to use Descartes' rule of sign to see how many possible positive and negatives we actually have. So first off, how many sign changes do we have of just the regular function? So let's just pick out. So we have 1, that's not another 1, and 2, right? Goes from positive to negative. So we have a total of 2 sign changes. Okay. And now we're going to do the same thing for f of negative x. So again, right, if I told you guys, so for instance, if I plug in negative x, since it's a third power, it's going to be a negative, and negative times a positive, negative times a negative gives a positive 2x to the third. Since it's an even number, that doesn't change the sign. This is an odd, so it gets negative 7x, and then minus 6. That. And now again, we count. So positive, positive, there's no sign change. Positive to negative, that's 1 sign change. And negative, negative, right? No sign change there. So when it comes to this, we actually have 1 sign change. So how are we going to use Descartes' rule sign? So let's just do the easy one first, this one. So we have 1 sign change. So how many even? What are the even numbers between 1 and 1? Hopefully you say none, right? There's no numbers, 1's not even. So therefore, what they're saying is we are guaranteed to have 1 negative 0. That's what this represents here. Okay, so I'll put this to the side. So we're guaranteed 1 negative 0 for sure.